Engineering leaders are hitting a wall. Despite a talented workforce and modern tools, delivery cycles stretch out, backlogs grow, and deadlines become moving targets. The standard response is to treat this as a performance issue. Teams are pushed to increase their velocity or improve their hiring standards to close the gap. But when output stalls across an entire organization, the friction is rarely found in the people. It is usually embedded in the very architecture they inhabit. Pushing for more speed without addressing that structural weight creates a silent productivity drain, one where developers work harder while the organization sees less. This strain is caused by a shift in how time is actually spent. In a legacy environment, the majority of the day isn't dedicated to writing code, but to decoding what is already there. Engineering benchmarks show that developers can lose up to 17 hours every single week just trying to interpret their own codebase. We can see this illustrated in a typical engineering workflow. A developer assigned a simple update must first navigate this dense network of logic, tracing how functions reference undocumented modules before they can even begin the implementation. Instead of building forward, teams work backward, reconstructing systems that grew organically over years. This results in the measurable time loss highlighted here. Without a clear source of truth, every task starts with a repeated discovery phase. When interpretation dominates the workweek, actual building becomes a reactive secondary task. This friction is built on three specific pillars. First, the breakdown of documentation. As shown in this pile of fragmented notes, over 40% of legacy code in the enterprise is either undocumented or inconsistent with current behavior. Second, invisible dependencies. This illustration of a physical network represents the reality of modern software. A minor change in one service can trigger an unexpected failure in an entirely different part of the system. The third pillar is a human one. Without a searchable system map, knowledge becomes siloed. Senior engineers become the only reliable way to understand how things work. This creates the cognitive overload shown in this left panel. Key experts find their time fragmented by a constant stream of questions, which interrupts their own work and slows down everyone else who is waiting for an answer. These bottlenecks eventually create a culture of hesitation. Developers avoid making necessary improvements simply because the systemic risk is too high to calculate. High-performing teams solve this by prioritizing system clarity before they start implementation. They ensure that understanding the code is an immediate rather than a manual process. This is where Code Aura serves as a productivity infrastructure layer. It uses AI to ingest these complex, fragmented codebases and transform them into a searchable knowledge base. Instead of tracing files manually, developers can ask questions in natural language and receive system-aware answers instantly. We see the result on the right. The pile of scribbled papers is replaced by a clean digital dashboard, documentation that is automatically generated and stays accurate as the code evolves. The tangled cables are converted into a transparent digital map, showing exactly how components interact so that developers can make changes with confidence. By moving knowledge out of individual memory and into an accessible system, the entire engineering team can move with independent velocity. If we return to the workflow model, the impact is immediate. The circuitous discovery process is replaced by this direct path to delivery. This split view shows the broader transformation. We move from the manual, high-friction environment on the left to an organized, automated digital factory model on the right. This change allows an organization to scale. Because knowledge is shared, adding new developers actually increases total output, rather than just increasing the communication overhead. There is also a significant impact on talent. Developers stay engaged when they are solving problems and building features, rather than fighting against opaque systems. In a market defined by high stakes and complex code, the teams that can understand their infrastructure the fastest will always be the ones that deliver the fastest.